All right, this is a different setup. I wasn't able to record the video at school, so this is what you get. We are looking at exponents and exponential functions. We're gonna start with number 6. So we have a chess tournament starts with 64 people competing. The exponential function is given to you. That's 64 times 1/2 to the power of x. I can tell it starts with 64 people, and every round, x is the number of rounds, every round it's reduced by half. How many people are remaining in the tournament after x rounds? All I'm gonna do, oh, I read that wrong. X describes how many, the equation describes how many people are remaining in the tournament after x rounds. How many rounds will pass? So how many, what's my x until 2 people are remaining? So I need to know, when does 2 equal 64 times 1/2 to the power of x? So I don't know what this x is. That's when I use Desmos. I have 64 to the 1/2. 0.5 is easier to type. Ooh, goodness. To the power of x. I don't really care about the graph up here. What I do care about is the table. I want to go down until I have only 2 people remaining. What's going on here? That's a 6. That's not a 64. Oh, goodness. This is going horribly. 64. Now look at the table. Here we go. It goes from 64 to 32 to 16 to 8 to 4. And there's where we have 2 people at 5 rounds into the tournament. So, 5. Next, investments. Determine the amount of an investment of $500 if the account earns 8% interest. 500 is my starting amount, times my growth rate, which is a percent. If there is a percent, you have to add or subtract it to 100. In this case, it is earning interest, so we add it to 100. That's 108. Move the decimal point over 2 places. 1.08 to the power of years. In this case, we have 12 years. So that's what I'm going to calculate on Desmos. So we have 500 times 1.08 to the power of 12. And it looks like 1,259. So choice D. Biology, we have this equation, 10 times 2.5 to the power of t. T represents the number of bacteria in a culture. After t days, how many will there be after 6 days? So all we're doing is taking that equation. Starts with 10 bacteria. It is a little more than doubling. It's being multiplied by 2.5 every day for 6 days. So 10 times 2.5 to the power of 6. And it looks like 2,441 bacteria after 6 days. Next, find the domain and range of that biology problem above. This is what we've been looking at in the last day or two. I need to sketch a graph of that. Desmos will give me a graph, but it'll be an ugly graph. I don't care how that looks because that's not the part that I care about. I don't care about all this negative area over here. So rather than use the graph they give me, I'm going to sketch it. This is my x, that's my y. I know we start at 10 and it is increasing as time goes on. So that's the only part of the graph I care about. The domain is the x values. So how far left does this go? That is 0. How far right does this go? It keeps going to the right forever. So it's all of the x values greater than or equal to 0. In this case, x is like my exponent. It's my days. I can look at any number of days after 0. Can't go negative. So there's my domain. The range is my y value. That's like the answer to this problem. So all the amounts of bacteria, well, it starts at its lowest point which is 10, that's the floor, and it has no ceiling because it goes up forever. So it's all of the y values greater than or equal to 10. 9a, depreciation. $60,000 piece of machinery depreciates. Depreciates means it goes down in value at the rate of 11% per year. About what will its value be in 5 years? So starts at 60,000. It is going down 11%. So we subtract from 100. That's 89. Convert it to a decimal. 0.89 to the power of x, which is years, which is 5. So I'm calculating that right there. I'm going to say 60,000. Don't do a comma. It won't work with a comma. 0.89 to the power of 5. That is 33,504. C. 9b, domain and range of that problem above. Similar to the one we just did. I don't care about the graph that Desmos gives me. What is the, oh, it's 60,000. I'd have to zoom way out to see it. You can tell that it goes down. Where was it? And kind of approaches 0 there, but that's an ugly graph. I want to sketch my own version. It starts way up here at 60,000 and goes down like that. The domain, again, is the x value, left to right. The leftist spot is at 0, and it doesn't have a right. It doesn't end over here. It goes on forever. So it's everything greater than 0. Greater than or equal to 0, because it is 0 at that exact spot. The range is bottom to top, floor to ceiling. I have the bottom right here. That's at 0. The top is all the way up there at its highest point, 60,000. It's everywhere in between. When it's in between, I say 0 is less than y is less than 60,000. Now it equals 60,000 at the beginning before it starts to decrease. At the bottom, it will never actually reach 0. That is the asymptote, so I do not have the equal to on the 0 side. Number 10, what is the domain, range, and asymptote of the exponential function below? So here we are looking at all the negatives. There's no reason to ignore them because they don't tell me to ignore them. So domain, left to right. It goes forever in both directions. So domain is all real numbers. The range is bottom to top. It does have a bottom. It never passes that boundary right there. That's my floor. That's down at -2. The top, it goes on forever though. So the range is all the y values above -2. Now, does it equal -2? It does not. That's the asymptote. So I don't put an equal to under there. The asymptote. There's a question on your test that asks about the asymptote. Asymptotes are always y equals something. That number is how far down or up the asymptote is. Most of the time it's at 0. This is a different, unique graph. It is down 2. So make sure you know that it's y equals whatever number. This one up here, for example, the asymptote right here would be y equals 0. You'll see that tomorrow. 11, Mr. Morrison placed an ice pack in the freezer and checked the temperature of the pack each hour. This is what he found. At hour 0, 73, 1 was 50.4, 2 was 36.3, and then 26.1. What is going on here? Uh-oh, my printer messed up. What exponential function models this table? And at this rate, when will his ice pack reach below 5 degrees? I can tell just from looking at this, 0 hours, 73 degrees, that is the starting amount. So my exponential function is 73 times something to the power of x. I know that this growth rate here is going to be smaller than 1 because this is shrinking. I just need to figure out how much it is shrinking by. In other words, 73 times what gives me 50.4. This is a problem we hadn't exactly seen. There is one like this on the test that's multiple choice. If this were multiple choice, I would just graph it in Desmos and hit the table and see which one gives me the matching table. Since I don't have multiple choice, I need to figure out 73 times what is going to equal 50.4. Well, that's an equation. I can solve for x there. Divide by 73. And the x, that multiplier, is going to equal whatever 50.4 divided by 73 is, which it looks like it is 0.69. So that's my growth rate, 0.69. To confirm this, I'm going to go graph what I think my equation is. 73 times 0.69 to the power of x. I want to look at the table, and does it match up? 0, 73, 1, 50.37, 2 is 34 points. Uh-oh. 50.4 divided by 73. Oh, I see what I did. Because I estimated a little bit. Technically, it's not 0.69, it's 0.69041. But that is a close enough estimate. These numbers here could also be rounded, so we're not going to be able to get exact here. This is as best we'll get. Like I said, the question here on the test is multiple choice. It'll be a lot easier to pick this out of multiple choice. I just wanted to make sure I didn't make any mistake before I ended that and showed y'all wrong. The other question, though, when will this ice pack reach below 5 degrees? If I go back and look at this equation and I keep going down, it is approaching 5 degrees. And it looks like at 8 hours, it's going to reach below 5 degrees. So 8 hours. That is all the exponential function questions there. Next page, we have some exponent rules and multiplying binomials. I'm not going to do all of these because there's 3 problems of every type. I want to do maybe 1 or 2 just to kind of give you an idea instead of 1 of each type, or instead of all 3 of each type. Number 12, we have multiplying binomials, or FOIL. 5x times x is 5x squared. 5x times 4 is 20x. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. Every time, combine like terms. 5x squared plus 18x minus 8. 13 and 14 are exactly the same. One trick on 13, when it looks like this with a binomial squared, that is this binomial, 2x plus 5, times itself. So 2x plus 5. I'm not going to go through and work those. I'm going to assume if you can work one, you can work the rest. Number 17, we have division. Our rules for division. Divide the coefficients. That is 3. 75 divided by 25. The x. We are subtracting the exponents. 3 minus 2 is 1. So I have x to the 1, or I can just leave it x. The y, be careful here with negatives. Negative 3 minus 2 is negative 5. That's y to the negative 5th. We can't have a negative exponent, so to fix that, we move it to the bottom, make it positive. Number 20, multiplication. we multiply the coefficients. -2 times 4 is -8. Coefficients can be negative. It's the exponents that cannot. The exponents here we add. So x and x, that's an invisible 1, that's an invisible 1. So I'm going to say x squared. Y, 3 and 4 gives me y to the 7th. I don't see anything tricky on 21 or 22, so I'm going to assume if you can do it once, you can do it 2 more times. 23, here we have powers to a power. We take this -4 and it goes to the second power. I do want to show you something here to be careful of. Go away. If I do -4 squared like this, it gives me -16. That is incorrect. I know that a negative times a negative, or -4 times itself, has to be positive. When you square it this way, it's not squaring the negative, it's only squaring 4. So 4 squared is 16, and then it makes it negative. You have to type in negative numbers in parentheses. It helps if you put the 4. You have to have the negative numbers in parentheses and then square it, and it gives you 16. So be careful if you're calculating these negative numbers. 16. We put -4 to the second power, not times 2. The big number, the coefficient, gets squared. These exponents, those are what get multiplied by 2. So A, 2 times 2 is 4. B, 3 times 2 is 6. Nothing else really looks tricky over here. 1/2 to the 4th power, just use your calculator. Keep it as a fraction. 26, we have a multi-step problem here. It looks like I have powers to the power on the left, another power to a power on the right, and then they get multiplied together. So again, 4 is getting squared, that's 16, and then I multiply the exponents. A, 2 times 2 is 4, B, 1 times 2 is 2. The next one, -5 to the 3rd power, is -5 times itself 3 times, which is 25 times 5 is -125. And then we multiply the exponents. A to the 3rd times 3 is a to the 9th. B is the same. 3 times 3 is 9. Now I have to multiply this times that. That is the multiplication rules. So I'm going to go calculate 16 times 125, -125. And it looks like -2,000. I'm multiplying the big numbers. Switch colors here. I'm multiplying the big numbers. 16 times -125. That gave me -2,000. I'm adding these exponents. 4 and 9 is 13. B of 2 and 9 is 11. So -2,000, that's annoying, 2 different colors. Oh well. -2,000, A to the 13th, B to the 11th. 29, 30, 31, 32, these are systems of equations. If you did those, great, but those are not going to be on this test, so I'm not going to waste time on the video doing those. They're not, it's not that they're not important, but just not for this test. Go away. That is everything. I'll be there for tutoring in the morning. If you got any questions, I will see you then.